Okay, so the problem that we're looking at is water is flowing into a cone, and the cone has a height of 16 centimeters and a radius of 4 centimeters. So water is flowing into a cone at a rate of 2 cubic centimeters per minute, and this is kind of what it looks like here. So water's flowing in, so the water level is rising, and we want to know how fast the water level is rising when it is 5 centimeters deep, 10 centimeters deep, and 15 centimeters deep. And one thing to notice is that the rate at which the height is changing is not constant, right? Because notice the height changes faster at the beginning than it does at the end because of the nature of the container, right? Whereas the rate at which the volume is changing is constant. So this is just in our minds to understand the problem. So when we look at that situation, a couple things that should stand out to us are, again, first, the height rises faster closer to the bottom. So in other words, the rate of change, so dH over dt, at h equals 5 is greater than dH over dt at h equals 15, for example. Because again, here at h, when the height of the water is 5, it's rising a lot faster than it is towards the top here. So the height rises faster closer to the bottom. Another observation that we might make is that the volume is changing at a constant rate. So volume changes at a constant rate. So in other words, dV over dt is just some number. And in fact, the problem tells us what number it is. It's specifically 2 cubic centimeters per minute. So imagine water dripping into the container at a constant rate. It's like when you turn on a faucet, right? When you turn on the faucet, the water comes out at the same rate, but depending on what kind of container is under the faucet, your height would change at different rates. So, so those are two things to notice about this problem. And then in the next video, we'll look at then setting up our variables and our calculation to actually solve the problem on paper. So again, this kind of initial video here is just kind of what happens, what should be going through your mind when you observe this situation, or when you think about solving the problem before you even write anything down.